My name is John Fuchs, like Lyra said. I'm an engineer here, and I work on our platforms team. And one part of our job on the platforms team is figuring out how to make it easier and faster to build Medium. Often we do that by figuring out best practices and patterns and formalizing them into abstractions that let a product engineer avoid or at least compartmentalize thinking about corner cases that could make a given approach better or worse. I'm going to talk about our patterns around what I thought was a pretty straightforward decision, which is when and where to query in a React application using GraphQL. But before I can get into that, I need to give you a little context on Medium's infrastructure and our ongoing adoption of GraphQL. When Medium launched 6 years ago, just about every user interaction went through a monolithic node application. It served page requests and our API requests, and it orchestrated fetching data for those requests, and it ran our business logic, and it talked to our data stores. And honestly, it was pretty great for a long time, but it has started to show its age. We didn't start the migration by saying we want to use GraphQL. As code bases age, new problems show up. We were finding that the concept of a component wasn't well represented in a way that could span data, styling, and behavior. Our APIs ended up sending data that was never used. Styles, templates, and behaviors of components drifted apart. And just as code bases age, so do companies. We had a lot of stuff that we invented ourselves, and we were feeling the weight of maintenance and education. And honestly, a not insignificant factor in choosing to migrate is that we chose some web technologies that didn't really win the race, and they didn't end up with large and active communities and everything that brings. Looking at you, Google Closure Compiler. When you build with React as a foundation, there are a bunch of subsequent decisions you have to make. What should we do about styling, metadata, building and chunking the JavaScript? And as we started to think about the data layer of this new stack, we found that GraphQL, and we chose Apollo client, those together gave us good answers for all of the issues that motivated the migration. We get co-location of components and their data needs. There's a large and active community. We can take advantage of great developer tooling, and it wasn't invented here. So here's what the new stack looks like. We relegated our node monolith to the role of just an API service, and we put a GraphQL server in front of that monolith. Also, we took existing API endpoints and slimmed them down to remove reference gathering, since our GraphQL server was already really good at that. Then we added a service whose single responsibility is server-side rendering of our React app. That service, as well as the web client app and our native apps, do all their fetching and mutating through the GraphQL server. Like I briefly mentioned, we're using Apollo's GraphQL client, and I want to quickly review the mechanics of queries and fragments of using Apollo client in a React application. Now, I don't know if you've noticed, but it seems like every example of UI-related technology uses a to-do list example. So here we go. This is a query that says, give me the items field, and from each item in the items field, I want a title and an is done field, which are probably a string and a Boolean. And here's a React component that composes Apollo client's query component to execute that query. And if you don't speak React, don't worry. So this component makes that composition. And the query component is what actually manages the transition from loading to having data and passes all of that state into its children as it updates. And from there, it's just a matter of mapping over the items supplied by the query component to make a list. So this is fine, but as your app grows, you realize that there's a lot of complexity behind rendering a single list item, so you make a subcomponent called list item, which is great, except now you have the to-do list query, which is logically part of the to-do list component, knowing about the implementation of list item. And that's not great because the list item can change over time, and if you're not passing the right data, something breaks, or you fetch data that you don't need. So instead, you make the list item component export a fragment and compose that fragment into the to-do list query. The fragment is a sort of contract that specifies the data that should be fetched for and passed to the list item component. Now the list item is free to change which fields on the item model are needed and can reasonably evolve as a separate component without our to-do list component needing to know anything about it. So that's a great example. In reality, your app's component tree will have a depth greater than 2. But you can compose fragments into your fragments, and the general concept stays the same. Any given component gathers its immediate subcomponent's data needs, probably expressed as fragments, along with its own data needs, and exports all of that in one or more fragments, and then that component's parent will implicitly know all of the data needs of all of its subcomponents without explicit connections to the implementation details of those subcomponents. All the way until eventually we get to a component that actually does the querying, receives the data, and passes it back down the tree. Fragments go up, data goes down. So this is pretty much the default pattern in our React app today. For any route, we have a component we call a handler. It's the highest component in the tree for that route, and it's responsible for fetching all of the data on a page. As we started building out our application, we had one simple rule: only query in the handler. Everything else can just pass a fragment up to the handler and expect data to come back down matching. And that worked pretty well for the most part. Here, for example, is a topic page on Medium. A topic page includes, among other things, a list of posts. And each post in that list has a bookmark button. Looks like this. And that bookmark button is rendered differently if the user has bookmarked that post. So to make those buttons work, to make those buttons on the topic page show the right state, we start with a bookmark button exporting a fragment on post, which is composed into the post listing item by lines fragment on post, which is composed into the post listing items fragment on post, which is composed into the topic landing feeds fragment on post, which is composed into the topic screens fragment on post, which is composed finally into the topic handlers query. At this point, I think it's maybe worth checking in to make sure this approach makes sense. So what's good about it? Well, data needs of components are co-located with the component. We don't have code that leaks or duplicates those data needs up the tree. And all of that means that maintenance of those components will be that much easier. And if you write a component as a pure function of its props and state, it's going to be easier to reason about and test a component. And finally, we had some assurance that our data fetching will be reasonably performant, since most of the hard work is delegated to a GraphQL server whose specialization is fulfilling those queries efficiently. So this got us to a working bookmark button, but of course, in software, things get complicated. Our particular complication was that Medium has paid memberships, and if you're a member, you can read paywalled articles and you get certain features, and one of those features was that the two-state bookmark button gains a third state for marking posts as read. My coworker who implemented this had some feedback for me. It was too much plumbing, or so they said. And my first reaction was, no, this is correct. React and Apollo are working just like they should. This is a very pure abstraction. But the more I thought about their experience and looked at the changes that had to be made, I ended up a little more empathetic to their protests. Getting the displayed state of the button used all the same fragments as above, and the new bookmark state was just another value on an enum, so that was actually not bad. But figuring out which behavior the button should have when it was pressed was going to require an entirely different piece of data, specifically the current viewer's user object. And none of those components we're looking at there had fragments on the viewer yet, so we had to change each of these components all the way up to the query. And that seemed bad. As a thought experiment, what if we just abandoned fragments altogether and had every component in the tree execute its own query? That would solve this particular mess and keep data co-located with components. Well, in React, the children of a component may change as the properties passed to that component change. So generally speaking, we have to wait for a component to receive the result of a query before we know what its children could be, and accordingly execute the child component's queries. So even in a world where you batch these queries together and you're caching results, you're still probably querying at least as many times as your tree is deep. We tried something else. In an attempt to balance containment, developer ease, and performance, we added a single reusable component that gave us the current viewer. Let's walk through what that would do for the bookmark component. So we start by passing in a post object corresponding to the fragment exported from the bookmark button component, just like we would have before. But there isn't a prop for the viewer object. Instead, we leverage our new with_viewer component, and we use it to access the current user and determine the right behavior. Here's the implementation of that with_viewer component. If you don't speak React, no worries. The thing to note here is that it's just a thin wrapper around a query component that passes the current user to its children. And here's the query. Looking at this, you might recognize that I was ignoring some very reasonable rules about co-locating components with their data needs. But I'm going to argue that that can be good or at least worth the maintainability cost. Given that we aren't using a different query in each component that needs different fields on the viewer, and given Apollo's caching behaviors, we can be confident this component will only hit our GraphQL server once, and that's once from server-side render across navigations in a page in the single-page application, across navigations within the single-page application, because we're passing our in-memory cache from the server to the client. And additionally, it doesn't include every field on the user object, only the fields we regularly need throughout the app. When we need values like, sorry, there should be something there. How long has that been going? Cool. Kind of on autopilot here. Okay. Sorry, it's like a road transition. Anyway, so this doesn't include every field on the user object, only the fields we regularly need throughout the app. And when we need more expensive values, like billing history or followers, we can always specify those fields through our regular fragment mechanism. And our type system can help us avoid expecting objects to have fields that haven't been queried. Here's an example of that. We generate flow types corresponding to all the queries and fragments in our application using an Apollo utility. And this is flow telling me that the viewer supplied by with_viewer doesn't have a field called billing history. So that's really handy. And seriously, if you're not generating types for your client JavaScript, I'm happy for that to be the one thing you take away, that is hugely valuable. So typing lets us know what data is available, but the trickier thing is avoiding querying more data than we need. And that's one of the big selling points of GraphQL. Certainly we could add fragments to the viewer, to the with_viewer query for some or all of the components that we'll need to use that we'll use with_viewer. But that also comes at a cost. Our with_viewer component would end up having knowledge about its callers, which smells really bad, and it makes the net benefit of this approach kind of questionable altogether. So maybe some overquerying is acceptable. What about performance? Let's say our application's component tree looks like this, with a with_viewer component under the topic handler. If our with_viewer component isn't added to the tree until the main topic handler query returns, then we're going to end up making those two queries in serial. And even though the with_viewer query is, it's a very fast query compared to fetching all the other data we need for the topic page, it's still on the critical path and it's affecting users. The solution we came up with is to just add a with_viewer component somewhere else in the tree, even if it doesn't visually affect the UI. We can ensure that the with_viewer query is not blocked by the larger topic handler request. And at this point, the expense of with_viewer as an abstraction becomes negligible. So if you've seen our with_viewer component, and I want to give you one more example of where we've generalized a specific kind of querying into a reusable component. At Medium, we have a system of variants and flags. Elsewhere, I think they're called experiment systems. But to us, variants are A/B tests or product rollouts, and when they're enabled for a user, they affect the value of flags. A flag could just affect the color of a button or the wording in some UI copy, but often they're determining higher level decisions about how an entire route is served. So let's say we want to run an experiment where users see an entirely different version of the topic page. And let's say it's not just a visual tweak, so we have two different screens that specify two different fragments on topic. Our topic handlers query could look like this, where the handler just fetches the data for both possible topic screen components and gets our flags all in the same query. And then it decides what to do when the data comes back from the query. But let's suppose that the data for each screen is different enough and expensive enough that we don't want to include an unnecessary fragment. There's another approach based in GraphQL directives. So you can define your own directives, and they're just annotations that are passed to a GraphQL server. Eventually, we want to support custom directives in our GraphQL server, but we're not there yet. So there's another trick about variant systems, actually. I want to tell you this first. Often, one variant will affect multiple flags, or we'll have multiple experiments that aren't meant to run together. So if we were to query two different flags at different times, we run the risk of running our application in a state that we haven't thought through or tested. At Medium, it's the case that there aren't too many flags, and it's pretty quick to just figure out what all of the current flags are for a given user at any point in time. And given that, we can mitigate the complexity of race conditions around intersecting variants by making sure that when we need a single flag's value, we actually query for the state of all flags, cache that set of flags, and then we'll just query from that cache as we need it. This might start to sound a little bit like our with_viewer component. Here's the with_flag component. It uses a query that, like I mentioned, just grabs a set of all the current flags. And like with_viewer, it's leveraging the regular caching behavior in the query component. This time, though, it's not just about performance, but it's also a mechanism to ensure consistency between our different flags. Here's an example of where we use with_flag to implement our alternate topic page experiment. Instead of using directives, like I mentioned, or fetching both screens fragments, we just serially fetch our experiment state, or rather our flag state, using with_flag, and use the result to determine which handler to use. Now, I'll admit that it's not ideal that we're blocking on our with_flag query, and we could implement something more complex in a one-off way, or we could build those directives. But I'd argue that for us, as a small company, at this stage in time, this is a good solution. It might be the right solution for us as we are just beginning our migration to GraphQL. And just about anything else in our application could be varianted. So another factor is the fact that if we need to variant a behavior that happens well before we even get to handlers, like at our page router, we would have to make this fetch ahead of time anyway. So that's with_flag combined with with_viewer. Those are two abstractions that we've introduced that we found helpful as ways to simplify product engineering. Looking forward, I'm curious about what other abstractions we'll add. I'm wondering when client performance becomes a problem, which I didn't touch on a lot, but suffice it to say, it's been fine for us so far with this approach, but it certainly does have an effect. I'm wondering about the fact that variant flags and viewers are conceptually part of a user's session and what that means. And I'm figuring out how we could use that to help optimize the performance of our stack and how abstractions like these could help specifically audit how we interact with session-specific data on a page versus the highly cacheable session-independent content. I'm thinking about the fact that we've introduced exceptions to the rules in a way that might help in the next year or two of product development, but also might hinder a refactor or migration later on. And I'm thinking about how to generalize this problem in ways that will reduce toil for platform and product engineers at Medium and everywhere else. Finally, I'd love to hear from you all, whether you think I've done something terrible, or if you think this is at least directionally interesting, or you think this is great. I hope I've shown you some of our thought process around the trade-offs between universally applying broad rules and reactively formalizing exceptions in ways that sometimes feel like a compromise. Thanks.